Hi everyone, Mr. Loy here. In this video, you will see how a hand-drawn working drawing is done based on the Secondary 3NA Steady Hand Game project. Now, if you are not from 2022 Sec 3NA D&T, you could be graduating classes. You'll be focusing on your own mock-up or prototype when you draw out the working drawings. Just to clarify a myth or doubt, typically when you have developed on paper your design, your final design idea, you would have tested out using your mock-ups for size, proportionality, and to some degree functionality, but not so for suitability of materials because you use recyclable materials such as foam boards, cardboards, newspapers, corrugator board, and so on. So in this video, the prototype has already been made, and for Secondary 3, it is good to refer to a physical object like your own steady hand game, and you can take measurements from there and then you draw your working drawings. Now, the design process is after your final design idea, you proceed to draw out your working drawings, create your bill of materials before you acquire the actual resistant materials to realize your prototype. However, for a designer, you may have used your mock-ups and then you have drawn up your plans. From your mock-up, you may have made improvements, modifications to it, and then you can proceed to make your prototype. Alright, this is not a finished product. Prototype is basically the very crude, very first early working model of your intended final design. So in other words, you intend to continue to realize a better prototype, maybe version 2 or even to a finished product. So in this sense, you can have your prototype like this, alright? Use your ruler, steel rule to make measurements, and then you draw out your working plans for subsequent realization of prototype. So in other words, what I'm trying to say is that your working drawings need not always be out first before you actually go into realization of prototype, which is the usual course for design process. In this case, the designer would have drawn up the working drawings, alright, after the prototype is made, so that it can continue to improve on the later designs. So if you're Secondary 3NA, you would have in the previous term, last semester, taken enough photographs of your own prototype. So this is just one example. This is a 3D view, alright, it looks somewhat isometric, a little bit from the bird's eye view. You may also have, or you're required to, make sure that you have a top view, or we call it the plan, P-L-A-N, and you have some reference using the steel rule and actually measured the overall length. Alright, we go for the maximum, the overall length. In this case, for my prototype is 26 centimeters or 260 millimeters. It's good to actually tilt your, or let your prototype lie down in this sense so that you can kind of like show the thickness. Alright, now of course you can see that my steel rule here doesn't put all the way here. It's because when you look at from the top, the actual prototype, when you take this photograph, the edge is actually over here. Alright, so if you understand what I mean by camera angle effect and things like that. So this is the actual measurements, alright, thereabout. What you need besides overall length is also your overall width. Okay, so this is the overall width. Now you realize that my the base of my prototype is not symmetrical, it is a bit irregular. So this part here is actually wider than this part here. So over here I actually measured based on the shorter width. So you can see the width varies from the shorter one, which is 10 cm or 100 mm, to the widest one, which is 13 cm or 130 mm. So you have your overall length, your overall width, in this case 13 is larger than 10, so we take 13, and as well as the overall height. Alright, so this includes the two vertical supports, so I'm measuring one of them. So if you can have a look, it is actually 22 centimeters tall. Now this is based from the base of the prototype, okay? So it's not measured from the base of the vertical support. So of course we know the thickness of the base is 12 mm or 1.2 cm. You can use 22, take away 1.2 cm, and then that is the actual overall length of the vertical support. However, for our overall prototype, alright, it's actually 22 centimeters. Now you need to have all these measurements ready, so that's why you were asked to take several photographs of it. And there are other parts that you may need to make working drawings of, so one of which is the handle, which is over here. So you have to make your own measurements. I did not take photograph of this vis-a-vis the steel rule. So I measured the diameter. This is the symbol for diameter, or you can write capital DIA. It's 12 by 70 mm. So in terms of centimeters, the diameter is 1.2 cm and the length of the handle is 7 cm. I also have my metallic holder. In this case, it's made of aluminium. So this is the piece I'm referring to. So before you bend it, alright, the overall length is 5.5 centimeters. The width is 1.5 centimeters, and the thickness of the aluminium is 0.2 centimeters thin, okay, or 2 mm. Now apart from that, you have parts like your circuitry, your joining materials like your round head screws. So your circuitry and your joining materials, you do not need to draw the working drawings. Of course, the wire course, which is made of nichrome wire, alright, you don't have to draw this as well. So what we need to show is the main part of your prototype, which is the base, the vertical supports, there are two of them, the handle, alright, and the metallic holder, because these are the four main parts of your steady hand game that you need to make. Of course, the dowels will be the one that we attach as blind holes here at the base of the vertical support to the top surface of your base of your prototype here. So in that sense, you may want to draw this, but this is classified together with the round head screws, so actually no need. So based on this, I am going to show you, alright, how to draw the working drawings. Now basically what you need is your A3 paper, and previously if you have already used the Vanguard sheet to make a mock-up, this is the easiest way. Of course you did not take home the Vanguard sheet, so therefore you can use your photograph that you've taken on your phone, and with the measurements you draw out the overall rectangle, and then you can draw freehand or using your flexi curve or your French curve if you have free curves like mine, or you use your steel rule to draw the straight lines. Okay, so in this case it's not really a sketch now but a proper drawing. Okay, so what I do is, for my case, I have brought the Vanguard sheet home. So you just trace along the outline like so. Alright, if not, the second method is you have already known the overall length, the overall width. So in this case you do not need the thickness, so with the width and the length you can draw a rectangle, and within that rectangle template you will draw the outline of the base of your prototype. Okay, so later I will just darken the outline. Just want to show you very quickly, for working drawings basically you need three views. This is the top view or the front view. If you take this as the front view, then this will be your side view, alright, your end view, and this could be a plan. Alright, so it depends on which surface that you're drawing and how you label the perspective. So for my case, I will consider this as my front view. Okay, there's nothing wrong labeling this as the top view or the plan view as well. And the next important drawing that you need is the thickness. Of course, this Vanguard sheet is very thin, but on the actual Gelotong base, it's 12 mm or 1.2 centimeters. So in that sense, you will need your steel rule or your ruler. You draw a very thin light continuous line like so. There is a gap here, all right? Do not touch the outline. This is the thin continuous line until it clears this area for you to draw a proper dimension line later on, okay? So you see there's a little gap here, all right? Then I'm going to put it down, thin continuous line. So with this as my guideline, I know that the thickness of my prototype I can draw here, all right? So I'm just going to take reference from the two extension line, or we call it the guideline, and I'm going to use my steel rule to draw the side view, or what we call is the end view. Now I know that it is 1.2 cm or 12 mm, so it's going to be here. All right, on the other end it's going to be here. 1.2 is here, and with the two endpoints here, I'm going to join and form a rectangle. All right, now the outline of your part that you're drawing should be dark, continuous line. So there should be a gap from the extension line coming from the front view. Okay, so this is my front, and then this is my plan view, all right? Or you can call this the plan and this is the front. Now previously, for ISO standard 9002, we need to have proper relationship. For example, if this is a quadrant, your front view, if you draw it here, your end view will be here, and of course below the front view is your plan, all right? Whatever you draw here must be related, okay? So in short, for general knowledge, all right, the relationship between the front view and the end view is actually the height, okay? The relationship between the front view and the plan is actually the length. And of course, there's also a hidden relationship between the end view and the so-called plan view, and that's the thickness, okay? So nowadays, you are not required to make very high standard of working drawings, because this is hand-drawn. So you do not need computer-aided drafting software, all right? You can use Google SketchUp, you can use Tinkercad, and make your own three-dimensional drawing as well. But this is for hand-drawn. So you can see that they may not be directly related, all right? And the drawings are not like side by side or one on top of the other very exactly. So one other view that I need to show is this end or this end, all right? So if I were to draw the end view here, all right, I would have drawn this part of it, okay, this part of it. If I were to draw here, all right, it's going to be here, all right? So I don't have space here, all right? I'm just going to make it here. And of course, you know, before you use your make your working drawings, you should sharpen your pencil, have your eraser with you, your steel rule, all right? So this is so-called my plan view, right? PLAN, or top view. And of course, I'm going to draw my end view here in this case, all right? So I'm going to extend my extension line, and there's one here, all right? I'm going to my labeling here, and don't forget to label your part, all right? So this is the base. So over here I have the extension line. I am able to draw my end view, all right? The thickness of your base is still 1.2, so 1.2 is over here, 1.2 is over here. So I'm going to make the extension, all right? Now for better accuracy, you can use set square, you know, the actual drawing materials. Now you don't draw the shorter length. Remember the shorter width here was is 10 cm or 100 mm, and this side was is 13 cm or 130 mm, because this is the maximum width, all right? So you can see that you have to project the maximum width and not just draw this bit, all right? Because from this end, all right, you can see the shorter width closest to you, and you can see the surface of the material going and stretching all the way to the end, which is over this side here. So you can see that this is my end view, so you can label it as end or side view, or sometimes we call it elevation, front elevation, end elevation, front view, end view, side view, all right, plan or top view. So you have three perspective drawings, all right, related to one another in this sense. So I'm going to pause here and touch up and enhance the working drawing in a short while. Okay, you can see that I've darkened the outline of each part view of the drawing. In this case, is the base of the steady hand game. I just want to also add a little bit of information for you that working drawings will show the details of where you drill holes, such as these two positions here. So likewise, it's also important for you to include the holes, all right? This is actually a blind hole for your dowel to be drawn here. You can use compass to draw the size of the hole that you will be using to drill. And of course, there's some form of reference, you know, from this end to this end, how far is it, and how far from the edge of the base you have to draw those things. I also want to add that when you take your measurements, it's always good to list all the measurements, all right? In this case, we can also refer them as dimensions. So it's easier for you so that you can create your bills of materials later on. Now, just want to also highlight that in this case, it's the actual size of the prototype that I'm making. This is the real size, all right? So what if you have your prototype larger than the A3 size paper here? Then in that case, you have to scale it down by 50% or 75% or 3/4. It really depends on how big your actual prototype is. So in that case, you have to have a scale, okay? So in this case, if it's scale 1:1, 1:1, we don't have to write, okay? But imagine that this prototype is actually twice. So for example, it's not 26, all right, but 52 centimeters long, the real size one. So when I draw on an A3, right, I have to divide 52 by 2, all right, if I'm scaling down by half, which is easier. So in that case, on your working drawing, on this piece of paper, you have to write the scale 1:2, right? So what it means is the one here shows you the measurements of your drawing, but your actual prototype is twice that, okay? So let me repeat. Scale 1:2 means you have scaled down your prototype half its size and draw it on the working drawing, okay? If it's the other way around, 2:1, so it could be something like an eraser, very small, and if you draw it 1:1, it's very small, all right, and you have details you can't see. So in that case, you have to blow it up, all right? Your actual prototype is small, but you have to blow up your drawing so that you can add details to it. In that case, you actually magnify it, so that's why the scale is 2:1. So in short, when you draw, imagine this is the eraser, all right? It's like 5 times big, all right, as bigger than the actual one. So if this is let's say 10 cm long, all right, your actual one will be 10 divided by 5 is actually 2 centimeters long. So you have to take note of that, okay? Now I'm gonna add the positions here later, but just to cut short the video, I've actually drawn parts of the vertical support over here, as you can see. All right, the vertical support before it's shaped, right? You realize that I make some curve here and things like that. So this is actually for the working drawings. So in this case, my vertical support is the name of the part that I make. You can see that this is my extension line. So extension line or guidelines, you use thin light continuous line, small gap, make sure there's a gap not touching the outline of your actual part. So in this case, the vertical support is a square rod, all right? It's a square pine, so it's symmetrical, all right? In other words, you don't have to draw a front view and a plan view because they both are the same, all right? They are identical. So in that case, for symmetrical object like your microphone or whatever, you just need to draw one front view and a side view will do, okay? Because the top view, when you rotate 90 degrees, it still looks the same. So this is redundant, all right? And of course, if you have already indicated measurements like this, you do not need to repeat the measurements on the other part drawing, okay? So you can see this is the side view, all right? So imagine this is my vertical support. So this is my front view, and then I turn here and look at the side view. So this is from one end of it. So like I was mentioning, if it's symmetrical, when you turn it 90 degrees to draw your plan view, it should look the same, okay? So of course, this is not the case because it's the thickness is not the same. So you can see that this is how you make representation. Just want to let you know that the line with the double arrow, all right, both ends with the arrow continuously drawn is what we call the dimension line. And of course, these are the extension and the guidelines. And of course, when you draw your outline of your part, it has to be dark continuous. So you can switch between 2B and 4B or 6B and so on, or you just vary your pressure, okay? Now, one more thing I want to highlight is that it's good to state on the piece of paper that you're making the working drawings all dimensions in mm or centimeters, so that you don't have to write the units of measurement every time you write the numeric or the quantity value here, okay? Now also for lengths, you write it the value in the middle of the dimension line, okay? In this case, it's on top and in the middle, on top and in the middle. Now what about for heights? Okay, if we were to rotate 90 degrees clockwise, the measurements values will be easily read. So in other words, for heights, you have to write it the same in the middle and on top of the dimension line if you can, okay? So this is the convention. Now just want to add a little bit more. Note that if the object or part is symmetrical, the two view, all right, will be enough, all right? So you do this, all right, is enough. So just like the handle, all right, you realize that if I were to turn 90 degrees to show the side view or the plan view, in this case, the side view, it will be the same. So I did not draw this drawing here. I just need to draw a so-called front view and the plan view, all right? So you can see that this is the pine handle that I made. So you can actually indicate cylindrical circular objects with the symbol of diameter, all right? In this case, it's diameter 12, which is at the bottom, which is wider. And then at the top, actually I chamfer it a little bit, so it's diameter 6. And because I draw it from the bottom here, I can see the bigger outline, the outline of my bigger base. And then of course in the hidden detail will be the dashed lines here, because right at the other end I have this shortened or smaller size chamfered surface here. So for hidden details, you know you cannot see from the surface of the part that you're drawing, but it's hidden behind, you use dashed lines. So diameter, you use this or this symbol, all right? Most of the time you use this. For radius, we use capital R. For center line of holes and things like that, you can use the CL, center line, to represent all the plus position like this, okay? These are the holes to be drilled on the metallic holder. So again, this is the front view, and then this is the end view, all right? And then of course you need to complete, all right, by extending here to draw the top view, okay? So you can see it from the side, but there's nothing much to actually show, very thin. So you still have to make one more drawing here. So you can see that with the relative dimensions, you can see that where the hole is to be drilled, how far from the base or how far from the top, and from which side, and so on and so forth, okay? So there's some missing information, such as this drill hole is a bit to the left, this drill hole is a bit to the right. So how far is it? You have to make the indications here as well, okay? So take note, joining materials such as screws are not needed to be shown in working drawings. For circuitries, you just need to make your circuit diagrams on another piece of paper will suffice. So this ends the working drawing training video.